So welcome back to KSR Biology. Today we are going to discuss about respiratory quotient. Which topic, ma? Respiratory quotient. What is this respiratory quotient? The ratio of volume of the CO2 evolved and O2 consumed in respiration, that is called respiratory quotient. What is the respiratory quotient? The ratio of volume of the CO2 evolved and O2 consumed during respiration or in respiratory process, that is called respiratory quotient. This respiratory quotient is also called respiratory ratio. It is also called respiratory ratio. Yes, see here. So the respiratory quotient is also called respiratory ratio or RQ value. It is also called which one? RQ. The RQ equal to the volume of CO2 evolved volume of CO2 evolved by volume of O2 consumed. Right. This is RQ. What is the formula of RQ, ma'am? Volume of CO2 evolved by volume of O2 consumed. Right? Yes. The RQ value is depends upon the type of respiratory substrate we used in respiration. RQ value is based on type of respiratory substrate we used in respiration. Right. So different types of organic compounds having different types of RQ values, right? Yes. See here, the RQ value or the measurement of the RQ value is done by which one? So Gannon's respirometer. Gannon's respirometer. So RQ value is measured by which one? Gannon's respiratory meter or respirometer. So RQ value is or the measurement of RQ value is done by Gannon's respirometer. Gannon's respirometer, right? So different organic compounds having different RQ values. For example, so first if you take the carbohydrates, so for carbohydrates the RQ value is 1. So why? What is the reason, sir? See, in carbohydrates RQ value is 1. Why? What is the reason? Why? Because see for carbohydrates RQ value is 1. Why? What is the reason? The reason is the amount of carbon dioxide and oxygen evolved and consumed is the same, so that the RQ value is 1. How? Now we will see. See, so if you take the C6H12O6 combined with so how many 6 molecules of oxygen, it gives rise to how much ma? So 6 CO2 plus 6 H2O and energy. Which one? Energy. So here, so what is the RQ value? See, if you take the RQ value, that equal to so CO2 evolved by CO2 evolved by O2 consumed. How many CO2 molecules are evolved here? So 6 CO2s by how many molecules of oxygen is consumed? How many molecules, ma? So 6 molecules of O2. See. So 6 by 6, that equal to 1. Where in case of carbohydrates RQ value is how much, ma? 1. I hope you are clear. Yes. When we come to fats, in case of fats, the RQ value is less than 1, that is nearly 0.7. Where ma? In fats RQ value is less than 1, 0.7. Why? What is the reason? In fats, right ma? The availability of the oxygen is less when compared to carbohydrates, so that they intake or they absorb much amount of the oxygen to oxidize the fatty acids during respiration. To oxidize which one, ma? Fatty acids during respiration, so that the RQ value is less than 1. For example, if you take the tripalmitum, Right now, see here, C51, H98, O6, two molecules combine with 145 molecules of oxygen. As a result, it get converted into, so 102 CO2s plus 98 molecules of water. So what is the RQ? Right, respiratory quotient. RQ value is equal to how much more? So number of CO2s evolved by number of O2 molecules consumed. See here, so number of CO2 molecules, how many? So 102 by, so what is the oxygen value? So here 145 oxygen. So it is equal to 0.7. So here, where in case of fats, RQ value is less than 1. That is 0.7. Right. Now, proteins. In proteins, the RQ value is 0.9. Where in proteins, RQ value is 0.9. Even in proteins, right now, the availability of the oxygen is less when compared to carbohydrates, so that they consume more amount of the oxygen to complete or to oxidize the organic substance. That means to oxidize the proteins during respiration. Right now, if the proteins act as a respiratory substrate, RQ value is 0.9, that is less than 1. Why? What is the reason? Because the proteins also having less amount of the oxygen when compared to carbohydrates, so that they intake, right now, they absorb much amount of the oxygen to oxidize the proteins during respiration. This is about proteins. Now, organic acids. Yes. So for organic acids, the RQ value is more than 1. Chalma? So more than 1. For whom? So for organic acids, RQ value is more than Y. Why? What is the reason? See here, so organic acids are rich in oxygen, so that they consume less amount of the oxygen when compared to, right, carbohydrates. So organic acids have more oxygen when compared to carbohydrates, so that they consume less oxygen and release more carbon dioxide, so that the RQ value is more than 1. Example for this, if we take the malic acid, so combine with 3 molecules of oxygen, so that it give rise to, so which one? So 4 CO2s plus 3 H2O. So what is the formula? Here RQ, respiratory quotient, volume of CO2 evolved by volume of oxygen consumed. So that, so how many CO2s are evolved here? 4 CO2s. Right? How many oxygen molecules consumed here? So here the number of molecules consumed here 3. So what is the RQ value? I think nearly 1.33. So the RQ value is more than 1 in case of organic acids. Right? So this is about organic acids. The next one is succulents. So what are these succulent plants? So the best example for succulents is Opuntia. So in case of succulents, the RQ value is which one? 0. In succulents, the RQ value is 0. Why RQ value is 0? Because in succulent plants, the respiration takes place during night time, but there is no liberation of the carbon dioxide. So which one? Consumption or absorption of the oxygen is taking place, but the liberation of the carbon dioxide does not take place. So that what is happening? So the RQ value is 0. RQ value is 0. So the next one, alcoholic fermentation. In case of alcoholic fermentation of the carbohydrates, the RQ value is infinity. Where na? Alcoholic fermentation. alcoholic fermentation of carbohydrates. Alcoholic fermentation of carbohydrates. So for this RQ value is which one ma? Infinity. RQ value infinity. Sir, how RQ value is infinity in case of alcoholic fermentation of carbohydrates? So in alcoholic, right ma, fermentation takes place in the absence of oxygen, means anaerobic condition. See here. So say 6H12O6. So do not combine with who? Oxygen, so that it get converted into two molecules of ethyl alcohol plus two CO2s. So CO2. So what is there any consumption of the oxygen here or O2? No, there is no consumption of the oxygen, but carbon dioxides are released. That means usage of the oxygen is not taking place, but liberation of the carbon dioxide is taking place. So that so the RQ value is equal to, so how many? 2 CO2s by 0. Which one ma? O2. 0 O2.